Hello everyone, welcome to Learn Overflow. In this video, we will discuss about the data types in Rust language. As shown in the in my last video, I am using this Rust playground, that Rust play.rustlang.org. So this is the place where I am using to type my type in the codes. So this is the place, and in this video we'll discuss about the data types. So Rust is basically a static type language. So you can say a statically typed language. Here, the compiler must know the exact data type for all the variables you use or you write in your code. Okay, like whatever variables are there to compile or run, the compiler must know the exact data type. Now, in this case, the compiler can usually infer the data type for a variable based on the bound value. Like the way we used to do in the last video. In the last video, if you've seen, we did something like let a equals 5. When it did this, the compiler itself got into the notion that a, like the variable a, has been bound to a integer, like has been bound to a integer type value or a number. So this is an like the integer type value, so it gets the type of the variable. Okay, exact data type, it gets the exact data type that it asks for. Now we can also make like we can give other type of specific, like we can specify the data type as well. So we can say you want a compiler to create a number variable with 16-bit integer. So we specify the data type as u16, and I'll tell more of what is a u16. There's u32, u8, u64, u128, all these are there. I'll tell one by one in this video as well. So like we want to specify the data type as u16, as we want a 16-bit integer. uh, to do that, we will do something like let a being the name of the variable, we'll just give you a colon saying a colon, then we'll mention u16, and then equals 5. Okay, so this is the thing we'll do. Just let me move the cursor here. Yeah, so this is the thing we will do. Look here, a let a colon u16. Here you are explicitly mentioning the compiler that you want an 16-bit integer. Okay, you don't want a 62-bit integer or a 64, not a 64, not a 32. Like usually the compiler takes this depending on the machine you use. If your machine is a 64-bit machine, then the compiler runs on a u64 on default. But you can specify in Rust what type, like the what is the length of the variable you want. Okay, let's run this. Let's try to get an output of here and see how we can what we can do. So after that we need to print it. We'll say print ln, and oops, yeah, print ln. We'll just try to print this as, say, just a basic statement, the number oops is, and we'll say this. Okay, the number is this, and we'll just print a. Done, we're done with this. Let's run this and see what happens. Now look, this works fine, and the type of the variable is the variable length you got is 16-bit. Okay, now what else we can do? If we can, if we enclose a number within quotes. Okay, if we enclose a number within quotes, like the double quotation mark, the compiler interprets the value as text rather than a number. Okay, the inferred data type of the value does not match with the u16 data type specified for the variable. So uh, here in this case, right, if you enclose this with the double variable, in this case you will get an error. Look, Here you can see, like, let it execute. uh, yes, here, if you notice carefully, here you are seeing an error. The error says expected due to this. It says expected u16 but found ampersand str. So it found a string but expected 16-bit integer. Okay, so here you can see that there's the difference. There's the difference. It is expecting something, and it is like, you can understand how these things works here. Okay, so that's the normal uh, error type, since like you can understand. Now talking about the built-in data types in Rust. So Rust comes with some built-in primitive data types to express numbers, text, or true false. Okay, so like the this you can say as integer numbers, you can say as floating point numbers. There is Boolean numbers and characters. So characters is like, you can use it as string as well. So there's a part of it. So Rust also offer more complex data types to work. Like, you can use string, you can use tuple values. So these are the complex values Rust also offers you. Okay, now let's deep dive into the numbers. The numbers, that is the integer and floating point values. So integers in Rust are identified by bit size and the signed property. So what I mean, look here. Bit size is this, how many bits you use, 16-bit, right? So bit size is that the number of bits you are using. And like, 1 second, yeah. So bit size is the number of bits you're using, and the other one is the signed property. So signed property is the u. By u, it is meant that it's a signed integer, and u is unsigned integer. Okay, look, I'll make you understand what is a signed and unsigned integer. A signed integer can be a positive number or a negative number. Okay, so you are giving a signed value, like if you remember the exact binary conversion of a number. So the exact MSB, like towards the MSB, you can see that there is an extra bit added at the last, towards the left hand side, like the far left, you can see an extra bit added for a bit integer. So if this is 1, then it's signed. If it is 0, then it's unsigned. Okay, so if that extra bit is there, that means this is a signed integer. Okay, so extra bit determines a positive or negative number. So that's the way signed integer can be a positive or negative number, and unsigned integer can only be a positive number. So that's the basic difference. Okay, so let's not deep dive into that binary conversion. So on normal terms, a signed integer is where you can see the positive and negative number. Okay, now what are the lengths possible? So here you can see u, or you can see I means signed integer. When you say I 16, wait, let me just convert this to 5. Yeah, so when you say I 16, that means this is an signed 16-bit integer whose value is 5. Okay, when you say u16, which was there beforehand, that means this is an unsigned 16-bit integer whose value is 5. Okay, the length, that is the 16, can be of different thing. Like, it can be of 8-bit, it can be 16-bit. 16-bit is what I am using. The thing you can see on screen is 16-bit. So it can be 8-bit, 16-bit, 32-bit, and 64-bit, and also 128-bit is also possible. And in all these bits, a signed value or an unsigned value is possible in Rust. Okay, so there is another thing that you can do in Rust, is an architecture dependent. So what is that? If you're using the architecture dependent thing, so that means it would, like, the compiler would see what is the architecture of your computer, like your program is running on. If your computer is a 32-bit machine, if you are using a 64-bit architecture machine, then depending on the exact architecture of your computer, Rust will infer all the programs. Like Rust will just convert everything depending on whatever architecture you are using it. Okay, that's the basic structure. Now if you want to use architecture dependent, then you cannot mention any particular bit. So in that case you need to mention u, then size, u size, or you need to mention I size. U and I are same thing. It's either signed integer for I and unsigned integer for u. So u I size and u size types depend on the type of computer your program is running. Okay, so it depends basically on the exact type of the computer your program is running. Look, then we need to understand about the, okay, let this execute. Yes, you can see that this works fine. This is not a different thing. After that we need to look at the floating point data types. Okay, so in Rust there is basically two types of numbers. Okay, in floating point, within this floating point I mean, one is 32-bit floating point, another is 64-bit floating point. If you want the number as 32-bit floating point, then you need to mention it as f32. And when you're mentioning f32, then make sure you are using that floating point. Okay, so f32 is basically saying that your computer, like the exact, the variable a should have f32 or 32 bits value of the floating number. Okay, let's run this. You can see this would not be a different thing, just a normal case. Okay, and another way, if you want a 64-bit number, then you should mention f64. So once you mention f64, that means that the number value or the length of the number is 64 bits. Okay, now here comes an important point. What is that important point? Is that the default floating point type is f64 by default. If I don't mention anything, then if I just mention something like this, a equal to 5.0, then the compiler would choose simply 64-bit. Okay, it would not choose 32. Okay, the 64-bit is roughly the same speed as the f32, like on any of the modern CPU that we use these days, but the 64-bit has a greater precision. So that's something you should know about the f32 and f64. Okay, now if you wish to try out the subtraction and like the operations we do, okay, on the number system, then Rust supports the mathematical operations like addition, subtraction, multiplication, division. So these are supported by Rust. You can do it something like uh, let's let's not take a value like this. Let's try to add or subtract numbers directly. Okay, look here, I'll simply use the println statement to do this part. How you can do that? Suppose you want to add two numbers. What are the two numbers you want to add? You want to add 1 and you addition with 2. Okay, so this should become something like this should work like this. Is the string part I'm writing now. How you can do that? If you're trying to do it directly, then you should do one, you should do unsigned 32-bit. You can obviously write signed I32 as well. So that basically use here one extra space because you are adding one with two, both are positive numbers, you know that. So there's no use of to keep a notice of the signed value, whether it's a signed number or not, right? So just simple thing, one unsigned 32 plus do 2. For 2 you can mention like, okay, let me just run it and show you first what this implies. Okay, so look here, this simply gives you that 1 plus 2 is 3. Now you can as well mention that 1 u32 plus 2 u32. You can mention that. If you do that, what would happen? Look, this works the same way. So you actually don't need to mention u32 for the second one, because it takes the value in that manner. Okay, the syntax 1u32 actually tells the compiler that the value of the value is the number 1, and to interpret the value as an unsigned 32-bit integer. Okay, so when you were once you were writing this, this is the what it implies, that the value is 1, and interpret this 1 as a u32-bit value. Okay, uh, if we don't provide type annotation, Rust tries to infer the type from the context. Here in 2 we didn't mention any type annotations, so Rust got like that, tried to infer the exact type from the context. Okay, from try to find out what can be its value, because u32 is used before, and it can easily understand that yes, by u32 it can work for 2 as well. Okay, so this worked. But if there is an ambiguous situation, I will put you in an ambiguous situation in few moments. Wait here. Let's try for subtraction. Say you want to subtract 5 from 8. Okay, so 8 minus 5. Okay, so if you're doing 8 minus 5 here, look how you can do that. For unsigned 8-bit, you cannot subtract a value. When you're subtracting, you need to mention that the value is a signed bit, because if you subtract, like if the subtraction comes in negative value, say I want to do 1 minus 2, so 1 minus 2 is come as minus 1, right? The result would be minus 1. To store this minus, we need to mention that this value is a signed bit, right? So here comes the ambiguous situation. Look what happens. 8, I I mentioned that this is a signed 32-bit 8, and from 8 I want to subtract 5. Okay, from 8 if I want to subtract 5, then this gives us a value. Fine. What if we don't uh, give anything? Look, for this kind of stuff, this like the value is there. Okay, now if we just do the other way around, if we subtract like the 5 minus 8, then you can understand what happens here. Okay, I'm just doing it here, 5 minus 8, and look, this would give you an error. Like no, this would not give you an error, this would simply run, because 5 minus 8, it would confer like this would consider as an unsigned bit. But what if you mention unsigned 32? You mention 5 as unsigned 32, and then you try to make the subtraction. Sorry, yeah, here look, the attempt to compute this, it got it, 5 unsigned 32 minus 8 unsigned 32, which would overflow. Obviously the extra minus sign we got as a result would overflow. So this is the case of ambiguity. Okay, the similar way you can do multiplication. For multiplication, simply do something like 5 into 8, and unsigned 5 multiplied by unsigned 8. So this would give you results in that same manner. There isn't any problem with that. For division, you can do float division, or you can do a normal division. There isn't any problem with that. It's as simple as like let me divide something like say 9 by 2. Okay, so 9 by 2, and 9 u32 sorry, 9 u32 divided by 2. Run this, this works perfect. Also you can just do uh, stuff like this. If you just mention 9.0 divided by 2.0, look, this is a normal case of f64. Why? Because by default Rust takes f64 for float values. This would give you a similar results. Okay, moving on, let's look, if you just notice, this gives you that 4.5. Okay, this takes the considers the value as f64. Now we have other data types as well, other data types like boolean. For boolean, the value would be true or false. Okay, so it's pretty simple. Boolean, if you say you have let a, and there you say a equals 1 greater than 4. Okay, if you do something like that, and ultimately if you try to print a, look what would happen. Okay, you were just trying to print a, it gives you false because 1 is less than a, and you put the value as 1 greater than a. So there is the purpose of boolean. For greater than, less than operation, greater than, equal to, less than, equal to, this kind of comparison operation, a boolean value is often useful, and the boolean value is often returned as a comparison check. Okay, like a true false, it can take only two values, either a true or a false. Moving on, we have characters and strings. So character is the char that we use in various places, and the strings are a combination of characters. Okay, so Rust supports text value with two basic string types, one and one character type. A character is basically a single item, when string is a series of all characters. Okay, so all text types are valid, like the UTF-8 representations are valid. Also, the char type we use at char type is the most primitive of the type text types. The value is specified by enclosing the item in single quotation marks. How? So look here. Simply, if you say a, okay, this is a character type value that we are storing in a. Okay, let's change the value. Let us compile. Look, just change the value because a and a is similar, looking similar. So we just change the value to something else. Look, that's how a character value works. Okay, look, it prints the v, so that's a character. But okay, there's something to notice here. You notice that I used a single quotes, not double quotes. That's important. For character we use single quotation marks, and when we use string we use a double quotation mark. Okay, so that's how it works. And some languages treat their char types as 8-bit integers, which is equivalent to Rust U8. Okay, unsigned 8-bit. So the char type in Rust contains Unicode points, but they don't use UTF-8 encoding. So a char in Rust is a 21-bit integer that's padded to 32-bit wide. The char contains plain code point value directly. All right. So that's something you should remember as well. That in like there are languages where char is actually considered as an unsigned 8-bit integer, but in Rust this is considered as a 21-bit integer, and usually we pad it to 32-bit wide. Okay, so that's the point with char type integers. Now we are left with two important types of data types, that are the string and the tuple. These are something a bit vast, and this I will share in tomorrow's video. Make sure you just watch tomorrow's video for string and tuple data types. So that's all for this video. Make sure you guys like this video, share it with your friends, and also comment down your thoughts of how you like of what you feel about this video. Okay, so thank you all. See you seeing you soon in my next video with string and